Areas between curves. The objective is to find the area between the two curves. Suppose S is the region between two curves f and g without lot of generality, assuming that f is greater than or equal to g from x equals a to x equals b. That is, f is the upper curve and g is the lower curve. We are interested in the area bounded by the two curves, the shaded region. But this region is not any of the well-known geometric shapes such as the triangle, rectangle, circle, squares, and so we can't just use one formula to find this area. To do that, we're going to estimate the area by dividing the interval a, b into many sub-intervals. We will divide it into n intervals. Each of the interval has a width of delta x. The area of this rectangular strip is therefore the height times the width, where the width is delta x, and the height is the upper curve minus the lower curve, f of x minus g of x. We take the interval a, b, and we divide it into n sub-intervals. Therefore, each of the sub-intervals, or each of the rectangular strip, has a width of delta x, which is b minus a over n. We start with x sub 0 equals a. We add delta x into a to get x sub 1. We add delta x to x sub 1 to get x sub 2, all the way to x sub n equals b. A representative rectangular strip lies in the interval xi plus 1 with a width of delta x. Therefore, the height is f of xi minus g of xi for the ith rectangular strip. The area of this ith rectangle is therefore the height f of xi minus g of xi times the width delta x. This is one of the n rectangular strips. The total area is estimated by adding n of these areas of the n rectangles. The total area A equals a sub 1 plus a sub 2 plus a sub 3 plus plus a sub I plus all the way to a sub n. Each of the rectangular strip has the same representation, f of xi minus g of xi, which is the upper minus the lower, as the height times the width, which is delta x. Therefore, we can combine them into one summation formula. The total area is the sum of f of xi minus g of xi times delta x as I go from 1 to n. But we recognize that this is the Riemann sum. And so, as n go to infinity, or delta x go to 0, this Riemann sum is the definition of the definite integral from a to b. If delta x approaches 0 or n go to infinity, there will be no error left. We obtain the exact area of the shaded region, and that is the definite integral of f of x minus g of x dx at x go from a to b. A and b are called the limits of integration. Thus the area A of the region bounded by the curve f of x and g of x, and the line x equals a on the left, x equals b on the right, where f and g are continuous, and f of x is greater than or equal to g of x on the interval a, b, then the area is the integral from a to b, f of x minus g of x dx. As long as f is the upper curve and g of x is the lower curve. Observe that if f and g are both positive, to find the area under the curve f and above the x-axis from a to b, we evaluate the integral from a to b f of x dx. Similarly, The area under the curve G and above the x-axis from a to b is the definite integral from a to b of g of x dx. Notice that the area enclosed by the two curves f and g is the shaded region. To find the area of this shaded region, we take the area under f minus the area under g, which is the definite integral from a to b of f of x dx, minus the definite integral from a to b of g of x dx. But these two integrals share the same limits of integration, so we can combine them to one integral from a to b f of x minus g of x dx, which is the exact same area that we just derived.